Hello, this is a review for the College Algebra final exam, and I'm doing a list of problems that I have seen many, many times on the final exam for College Algebra. The first example I'm doing looks like this. And the first step in solving this equation, which has fractions, is to clear the fractions by multiplying them by the least common multiple of the denominators, which in this case is 2 plus x and x plus 4. So we're going to multiply every single term in the entire problem by those two things. And this will eliminate every denominator that there is. So cancel out each denominator into whichever part of the least common multiple that it goes into. And then what you'll be left with is only a lot smaller than what you started with. You have to put this into parentheses because it's a group of more than one thing. So let's distribute these parentheses. X times 2, x times x, 6 times 2, and 6 times x. Then add the like terms. Two x plus 6x is 8x plus 12. Subtract the x squared from both sides. Then left with 4x equals 8x plus 12. Now subtract 8x from both sides. You'll be left with negative 4x equals 12. Divide by negative 4. Look at x equals negative 3. You have to make sure that that's not one of the values that makes the denominators be 0. So in that denominator, x cannot equal negative 4. And you should also write down that in this denominator, x cannot equal negative 2. So that proves that the answer x equals negative 3 is correct. Now let's look at problem number 2. We're going to solve this problem by using the square root property, which says that if you have something squared equal to a number, that what is inside of the square, which is this part right there, that what's inside of the square is equal to plus or minus the square root of the number on the other side. And the square root of 32 can break apart into being the square root of 16 times the square root of 2. So we're left with 3x minus 5 equals that. But the square root of 16 is 4. And so we're left with 4 square root of 2. Next, we need to move this negative 5 over in front of that plus minus sign. That changes it to be positive 5 plus or minus 4 square root of 2. Then we need to divide the 3 right here. Divide that 3 underneath everything that's on the right side. So we're going to have x equals 5 plus or minus 4 square root of 2 all over 3. And that's the solution for that problem. Now let's go ahead and do my example number 3. This one says 15x squared minus 8 equals negative 14x. The first step is to write the negative 14x over on the left side. So then we'll get 15x squared plus 14x minus 8 equals 0. Now we're going to start factoring this. So to factor it, we have to take off the square from the first term, but temporarily we're going to leave the rest of it. So we're going to write 15x and 15x. Next, we're going to bring this sign down, put it there. Next, we're going to multiply this sign times this sign. Positive times a negative is a negative. So we're going to put a negative into the next factor. And then we're going to connect this number to this number. We've already figured out the signs. So the signs don't matter at this point. We're just going to try to factor out those numbers into two groups. So 15 breaks apart into 3 times 5. 8 breaks apart into 2 times 2 times 2. Now we need to group those numbers into two groups so that when we put them into one of these blank spaces, that together they will add up to make the number in the middle of the problem. So how can I group those numbers together in a way in which it'll create a value that if I put it in the two values in the blue boxes, that I will get a positive 14? Let's just think. Well, what if I put the what if I put the 3 alone, let's just say, and do this group? So that would make 3, and 5 times 2 times 2 times 2 is 40. So if I put a 3 and a 40 together into those parentheses, I'll get a 37. That does not work, right? So let's try grouping together maybe a 4. How about if I put the 2 and the 2 into a group and the 3 and the 5 and the 2 into a group? So 2 times 2 is 4, and 3 times 5 times 2 is 30. That'd have a difference of 26 if I put those numbers in the blue boxes. That's not quite right. What about if I did just a 5 in one group and all the other numbers in the other group? So then I'd have 2 times 2 times 2, that's 8, times 3, that's 24, and then the 5. The difference of that is 19. That would still not make a 14. So what about if I did the 2 and the 3 together? That would make a 6, and then the 5 times the 2 times the 2 together, that would make a 20. The difference between 6 and 20, it is equal to 14. And I have to put the biggest one first. So put the 20 in this box and put the 6 in this box. So that makes the values that came from the first and last numbers together. And when I put them into the blue boxes, that it creates a positive 20 and a negative 6, which creates the 14 in the middle. So from the last two numbers, the last number and the first number, you have to create a number that gives you the middle number. There we go. So from the outside numbers, you have to create the middle number. Now, this is not finished yet. We have to eliminate a 5 from this parentheses. We have to eliminate a 3 from that parentheses, because any number that goes into it has to be eliminated. So then we'll get 3x plus 4, and then 5x minus 2. And this is still equal to 0. So then we'll set both of those factors to 0 after finishing factoring. And we'll move the 4 over to the right side. It becomes negative 4. Move the negative 2 to the right side, it becomes positive 2. Divide by the 3 on the other side and get x equals negative 4 over 3. Then x equals 2 over 5, like that. Perfect. All right, so that one's finished. Now let's try problem number 4. It says square root of 2x plus 3 minus 4 equals 0. So we're going to move the 4 to the right side. And when you have a square root equal to a number, you do something that's opposite of the square root property. And this says that what's inside of the square root, it's not equal to the square root of the other side, it's equal to the square of the other side. So 2x plus 3 by itself equals 4 squared. So that means 2x plus 3 equals 16. Then you move the 3 over after the 16 and get 16 minus 3. So you get 13. Then you divide both sides by 2, and you get x equals 13 halves. And that is the fourth example that I have. So let's try the fifth example. Which looks like this. So the first step is to get the absolute value by itself. Subtract the 2. Okay, 9. Now, if the absolute value equals a negative number, that's impossible, so there's no solution. But this absolute value does not equal a negative number, so there is a solution. And the way to find the solution is once again to look at what's inside. So what's inside of an absolute value, if it equals a number on the other side that's not negative, what's inside of the absolute value by itself could equal to either a positive or to a negative value of that value. So 3x minus 5 equals either 9 or 3x minus 5 equals negative 9. Next, I'm going to add 5 to every side. Next, I'll divide all the way across by 3. If I do that, I'll get x equals 14 over 3, and x equals negative 4 over 3. So those are the two solutions to example number 5. Next, let's look at example number 6. And it says x plus 3 squared plus y minus 5 squared equals 25. And that says find the center and find the radius. Well, and this is a circle, by the way, which has a center and radius. So what's the center? The center is actually the opposite of the number that is inside of the power of 2 with the x and with the y. So the x value is the opposite of the value that's with the x. The y value is the opposite of the value that's with the y. So just remember to do the opposites. The radius is equal to the square root of the number that's on the right side of the circle's equation in standard form. So the square root of 25 is 5. So that's example 6. Find the center and the radius of the circle. Next, let's do example 7. 7 says log base 3 of x plus 4 plus log base 3 of x minus 4 equals 2. So the first step is to join these two logarithms together. If they're added together, then the way to join them together is by multiplying the values that are in the logarithms together. Like this. If the logarithms are subtracted, the way to join them together is by dividing the two values together. So in this case, they're multiplied. So, in this case, they're added. So you change the addition of two logarithms to be one logarithm that has them multiplied together. The next step is a little strange. You do what's called exponentiating both sides, which means you put oops, I did the wrong number. I'm sorry. You have to put a base under both sides that's the same as the base of the logarithm. And this logarithm is base 3. So that means we need to put a base 3. I was looking at something else, and so I did a base 4 by mistake. But we're gonna do actually a base 3 on this one. So 3 to the power of log base 3, that actually eliminates each other. So this base 3 and the power of log base 3 cross each other out. So then the only thing left is just the inside, which is what we multiplied together before. Then on the right side, 3 we have to the power of 2, which is 9. Then we go ahead and multiply this out. So x times x is x squared plus 4x. Sorry, I did the wrong order. X times negative 4 is negative 4x. 4 times x is plus 4x. And then positive 4 times negative 4 is negative 16. And then negative 4x plus 4x cancel each other out. So you get x squared minus 16 equals 9. So subtract a 9 from both sides. You get x squared minus 25 equals 0. Then you can factor this out into being x minus 5 times x plus 5. If you set x minus 5 equal to 0, you would get x equals 5. If you set x plus 5 equals to 0, you get x equals negative 5. However, though, when you plug the negative 5 into the parentheses right here, negative 5 plus 4 is negative 1. And you cannot have a logarithm that has a negative value, and you cannot have a logarithm that has a 0 value inside of it. So even though this is a correct result, this is not actually the solution. So that one's not the solution. However, though, this one, if I plug the 5 into this, 5 plus 4 is 9, and that's positive. And then if I plug the 5 into this one, 5 minus 4 is 1, which is also positive. So this problem can work in both of the logarithms. So this is a true solution to the equation. So every time you solve a logarithm equation, you have to make sure that the solution is a true solution by making sure that it makes the logarithms both have positive numbers inside of them when you plug that value back into the original equation. Now let's look at example 8. Negative 1 less than or equal to negative 2x over 3 plus 5 less than 11. So we need to get x to be alone to solve this. So to do that, I'll subtract 5 from all three sides. Then I'll get negative 6 less than or equal to, this 5 crosses out, so it's only a negative 2x over 3 less than 6. Now let's clear the denominators by multiplying. This is kind of like the first question that we did. When you have fractions in an equation or in an inequality, you multiply every term in the inequality by the least common multiple of the denominators, which in this case is just 3. So multiply them all by 3. Then this denominator will cancel into that 3 and be gone. And the rest of them you have to do the hard way. So negative 6 times 3 is negative 18, less than or equal to negative 2x less than 18. Now we have to divide by a negative. You divide everything in the whole problem by a negative 2. However, when you divide an inequality by a negative, you have to switch the signs of the inequality. So the negative 18 becomes a positive 9. The less than or equal to becomes a greater than or equal to. The negative 2x becomes a positive x, because negative 2 divided by negative 2 just leaves you with a positive 1x. And then the less than sign changes to a greater than sign. And 18 divided by negative 2 is negative 9. So we've solved the inequality now, but we also need to graph this solution on the number line. So if I draw a number line, negative 9 goes first, and then positive 9. Then there's a solid dot at positive 9. There's an open dot at negative 9. And then you shade the values that are between them. So that represents x. Is between those. And it can equal 9 because it has an equal sign next to the 9. And it cannot equal negative 9 because there's not an equal sign next to that. Then finally, what's the interval notation for this? Well, the solution goes from negative 9 to 9. So you write that from where it goes from and to, from that to that. And then if it equals a number, you put a bracket beside that one. But if it does not equal a number, you put a parenthesis beside that one. So that's the solution in interval notation. Now let's look at question number 9. Question number 9, it shows us 3x minus 5y equals 3. And then it says 2x plus 3y equals negative 17. So what we have to do is try to figure out how to either eliminate the x's or the y's. So 3x and 2x can be combined together into a least common multiple, which is 6x. Or you could also take the 5y and 3y and get them to become 15y. But 15y is a bigger least common multiple than 6x is. So I'm going to go with getting rid of the x's by making both of them become positive and negative 6x. So to make the first one become 6x, I need to multiply it by 2, because 2 times 3x would make 6x. To make the bottom one become negative 6x, I need to multiply it by negative 3. So there we go. If I do 2 times the top equation, I would get 6x minus 10y equals 6. If I multiply the bottom one by negative 3, I'll get negative 6x minus 9y equals positive 51. Now I'm going to add them up because now the x's will get rid of each other. So 6x plus negative 6x is nothing. So this plus this is negative 19y. 6 plus 51 is 57. Then if I divide by negative 19, I would get y equals negative 3. Now to find x, it's best to just substitute the y in to the easiest equation that you can find to do that. And I think the easiest equation that I can find to do that would be the very first equation that I had, which is 3x minus 5y equals 3. So I'll take the y equals negative 3, I'll erase this y, and I'll substitute into it that value of negative 3 in the place of the y. And then I'll work that out. So it'd be 3x again, negative 5 times negative 3 is positive 15, equals 7. Subtract the 15 to the other side. Oh, so subtract 15. Then it's gone from the left side. And you have, on the right side, you have 7 minus 15, which is negative 8. Oh, I made a mistake, actually. Hold on just a second. My writing was so sloppy, I didn't realize that that's this number right here. That isn't really a 7. That's actually supposed to be a 3, because that equation came from this equation. 3x minus 5y equals 3. So let me fix that real quick. Change that to a 3, which it really should have been. So that actually should have been a 3. And so 3 take away 15 is actually negative 12. So that's my fault. So now we will get 3x equals negative 12. And then if I divide by 3 on both sides, I'll get x equals negative 4. So the solution is, as an ordered pair, you put x first and then y. So the solution is negative 4, negative 3. Now let's go ahead and do example number 10. The number 10 says the time that's required to do a job. So that's t. It says that it varies inversely. So if it says that it varies inversely, that means k divided. If you ever do a problem that says something varies directly, that means k multiplied by something. If you ever do a problem that says something varies jointly, that means that k is also multiplied by more than one thing. So if it says that something varies inversely, that means that you have k, then you have divided by something else. So this problem says time varies inversely as the number of people. So people is p. Then it gives you some more information. And it says if it takes 45 hours of time for 8 people to do a job, then how long will it take? Then how long will it take for 9 people to do the job? So first you know what time it takes, and you know how many people that there are. So let's plug in those numbers first. So if the time taken is 45, and we don't know k, and the people is 8. Then we'll get 45 equals k divided by 8. So we can cross multiply this 8 from the bottom of the right up to the top of the left. So 45 times 8 equals k, and that would be 360 equals k. So now I'm going to go ahead and do the second part of the problem. I'll solve for that. So in the second part of the problem, I have time equals k over p again. And now I don't know the time, so time is unknown. But I do know the k, though. It's 360. And this time the number of people is 9. So the time is 360 divided by 9, which would equal 40. So it would take 40 hours for 9 people to do the job if it took 8 hours for 45 people to do the job. Then let's look at number 11. Number 11 says, find the exact value of the logarithm ln of e to the power of 5.73. To do this problem, you have to understand that the ln is an abbreviation that means log base e. So you should rewrite the ln as log base e. And then we should use the property of logarithms and bases that says that if you have a log base e, that will get rid of a regular base e. So those are gone. So the answer is nothing but 5.73. So that's the solution to that problem. It's not bad at all.